Thank you very much for taking your time to attend this webinar. So today we'll introduce latest Renesas winning combinations, which are system solutions on battery management system and traction inverter applications. So my name is Masuo Okuda from Automotive Analog Marketing and Advanced Engineering Department in Renesas Electronics. So here is today's agenda. We'll begin at looking at the overall market and market trends and at first. So then we'll show xEV product portfolio in Renesas, and we will then show you how Renesas is bringing optimized combinations of digital and analog products into today's battery management system and traction inverter applications. So let's begin with a look at the market and megatrends and the xEV trends at first. So in recent years, the automotive industry has seen the acceleration of trends such as automated driving and electrification, and the traditional human-driven gasoline-powered vehicle is undergoing a major transformation. The key players that will realize this once in 100 years transformation of the automotive industry is nothing but semiconductors. So new technologies such as automated driving and electric vehicle are revolutionizing. To enable the new technologies, the electronic architecture inside the vehicle is undergoing revolution. So amid these changes in the automotive industry, we are focusing on three key areas: electric vehicle, e-architecture, and automated driving. And also we are developing solutions to solve our customer design challenges. So today we will focus on xEV applications. So let's see market changes in xEV. So as you know, on a long-term case trend and carbon neutral policies to 2050, the market is clearly shifting toward battery EV. So with the accelerating shift from conventional gasoline vehicles to electric vehicle, that is xEV, so a possible transitory step to battery EV seems likely in China, but it could also occur in EU and the US markets. So Renesas is focusing on xEV application also. So let's take a few moments to look at our portfolio for xEV. So we have a very rich portfolio of products that we can offer in the xEV space, which very well complement what Renesas was previously offering with MCUs, SoC, and power solutions. Specifically in analog and connectivity, we see a lot more opportunities with the new products that we have. And overall, the serviceable market that we see with the product. So we have has expanded significantly. On the power device side, we are actively investing in differentiating MOSFET and IGBT solutions. So we also recognize as Renesas that silicon carbide will be an important technology for the xEV market going forward. And we are evaluating and exploring options to internal and external to make sure that we are able to offer SiC-based product in the future. So with the product portfolio and differentiation, Renesas is positioned to succeed and offer complete platform for xEV applications. So we have the capability not only to offer digital analog power and software together, but also make sure that the interaction of these products is optimized to offer the best system performance possible. So there are some examples of xEV applications shown here. So whether it is for traction inverter, onboard charger, battery management system also. So even simple supply for different sections of the car space. That whole system can be offered by Renesas and is being actively optimized to give the best performance at the system level. If you look at it quickly, the battery management solutions, which is another area, we can offer turnkey solutions. So we have qualified MCUs and the battery management solutions. So battery management solutions which offer highly accurate and scalable options. So when we combine that hardware with our ability to offer application software, driver software, as well as specialized software, that has a better, quicker understanding of the battery health. We offer complete solutions for our customers to integrate that in their product and go to commercialization as fast as possible. So now let's see about our winning combinations. So we will focus on offering a SaaS solution called winning combinations, which combine our digital, analog, and power products. So instead of using standard products, these system-level optimized SaaS solution can easily solve unique automotive challenges, such as functional safety and power efficiency, and help customers reduce development costs and among hours. So emerging customers in the automotive industry will benefit greatly from this winning combination solution strategy, since they can speed up the time from product planning to market launch. So Renesas is seeing a strong interest from customers in the effort. So we've made for helping define compatible devices for their applications. So winning combo are helping our customers reduce their R&D time, reduce development expense, while improve their time to market. So this is the fundamental purpose on our winning combinations. On the xEV winning combo aspect, so we are offering optimized solution which are scalable based on the application. And we are focusing on make sure that our software is delivered along with our hardware, and the combination of software and hardware provides the best optimization for our customers. So with the combination of our analog power and digital capabilities, analog with our strong focus to improve our methodology and focus on reliability and function safety, where we have always received very good feedback from our customers. So we are in a great position to offer complete system solutions. So integrating our digital, analog, and power content, and also enable fast time to market for our customers with these solutions. So now let's see our two latest winning combination for the xEV space. So first one is the Automotive VMS application models and software. So as you know, to ensure safe battery use in the automotive industry, so battery management system is required to estimate the state of charge and the state of health on the battery cells. So developing an application to estimate the state of charge and the state of health, so it is needed to have a great deal of effort. So we'd like to reduce this point. So one way to reduce this effort, so that to improve the completeness on the design phase. So that means to reduce redesign and rework after validation phase. So Renesas provides a sample application models and software to estimate the state of charge and the state of health to reduce customer development efforts. So the sample application model allows customers to simulate application level behavior on their PC. So it can be increase a degree of application completeness during the design phase, and so that means reducing the rework. The sample application software and the driver software will also reduce customer software development effort. And finally, so we also prepared the application node that is covered the steps from simulation on the PC to the software execution on the our reference board. So the application node is also reducing the effort on the customer to run the Renesas environment. In the following slide, so we introduce the reference board and the recommended devices, the software execution environment, and finally PC simulation model will be also introduced. So this slide shows a reference board and Renesas. So we offer two types of reference board for software execution environment. So there are two options. The first option consists dual-core RH850 P1M CPU and 5 battery management ICs, that is ISL 78714. So with high measurement accuracy and excellent long-term drift performance. And the second option consists is a cost-effective single-core RH850 F1KM CPU board and a single battery management IC. So customer can choose options according to their preference on two options. So this is the recommended devices on our solution. So the recommended devices are followed here. So you can see more detailed information on Renesas public website also. So next, I would like to explain the models in the simulation on the PC. So our models consist of the reference board, the reference board, the current load for charging and discharging, and the battery. And so the micro model is also in the reference board model. And the micro model includes the application model that is estimated the state of charge and the state of health. So the application model estimates, I would like to say again, so application model estimates the state and parameter of the battery from the voltage, current, and the temperature. The result can be viewed on the viewer on their PC. So that is an example. So let me explain an example of the checking with the result on the viewer. So you can check the estimated status of the charge rate. That is the upper left side here, charge and discharge. So which is one of the battery states. And resistance and the capacity on the right side, so which are parameter of the battery equivalent circuit. So you can also see the equivalent resistance on the viewer. So I also would like to introduce the Renesas evaluation environment for the BMS application software. So we are thinking to evaluate the software. So an actual battery or battery simulator is required to to evaluate the safe. So for the safety, so Renesas uses a battery simulator to validate our application software for safety and reproducibility. So anyway, so we would like to introduce this environment also. So finally, the current development environment is shown in the table below. So we plan to expand the list in the future, taking into account feedback from customers. So let's move on the next winning combination for traction inverter. So I want to hand over to Tsubota-san that your inverter part session.
Hello everyone, my name is Masashi Tsubota. I'm in charge of functional safety of inverter system at Renesas Electronics. From here, I will explain about the functional safety concept for xEV inverter system. First of all, I will briefly explain about the inverter system using Renesas reference solution as an example. The xEV inverter reference solution is a practical design with a maximum output of 100 kilowatt, a very compact size of 3.9 liter, and high efficiency. It is already in mass production at a customer. Renesas can provide customers with a turnkey solution equivalent to an A sample. As a semiconductor manufacturer, Renesas is able to design and support solutions that take full advantage of our knowledge and MCUs and devices. For example, it takes time just to read and configure the thousands of pages of our user's manual for MCUs. We can help you take advantage of the best configuration method in the fastest possible time. In addition, mass production can take advantage of inexpensive EMS with no Tier 1 or OEM restrictions. The solution utilizes key Renesas devices optimized for inverter systems and is designed to maximum performance in both hardware and software. Renesas has a motor dyno where inverters can be evaluated and motor parameters can be calibrated. This inverter achieves up to 99% efficiency. Renesas has also implemented its inverter in a mule car to verify and evaluate its operation. We have also confirmed that the inverter is practical enough to withstand the customer's initial vehicle installation tests. Let's watch a short video together.
Renesas Electronics xEV Inverter Reference Solution. This reference design from Renesas Electronics offers the world's smallest 100 kilowatts class inverter to address the rapidly growing market for electric and hybrid electric vehicles. The hardware design is complemented by a calibration tool to maximize the performance of the motor and motor control software to optimize the performance of the host microcontroller. The hardware design includes the Renesas RH850C1MA2 microcontroller, optimized for motor control with a built-in resolver to digital converter, power management IC designed specifically for RH850, high-voltage gate driver with built-in micro-isolator technology, and the IGBT and FRD power stage devices. Using this 100 kilowatts class motor bench, Renesas can accurately measure motor parameters and evaluate system performance using the incorporated hardware and software. Renesas is also readily available to help customers realize new requirements at the system level. Renesas has built up a demonstration vehicle equipped with this inverter and confirmed its performance in actual driving environments. Customers can utilize this solution to easily realize a highly efficient system and immediately evaluate a prototype inverter system in an actual vehicle. Prototype development that typically takes 2 to 3 years can realistically be cut in half.
Next, I will explain the functional safety concept for xEV inverter system. Renesas has created the work product in accordance with the functional safety process by utilizing its experience in developing inverter reference solutions and its system knowledge. The ISO 26262 international standard for functional safety is increasingly being applied as a standard to evolving automotive applications. Optimization of these functional safety functions requires time-consuming, system-dependent safety analysis and evaluation. For xEV inverters, Renesas can help customers shorten development time by supporting functional safety at the system level. Easy to start system development with functional safety by using the reference work products for development phase, from concept to system design, that technical safety concept implementation. This is a block diagram image of the traction system. The vehicle ECU manage the throttle pedal and brake pedal information from the driver, automatic driving command information, and energy for the entire vehicle. The vehicle ECU send torque and speed command to the inverter ECU through the CAN interface. The inverter ECU controls the traction e-motor according to the torque or speed command. The traction e-motor is connected to the wheels via gears. The generator e-motor is connected to the engine in the case of xEVs. Boost back control boosts the battery voltage to the e-motor drive voltage. The boost back and generator function depend on the system configuration and can be installed as options. In this activity, the boundary of item is defined as a dotted line. We define assumption of hazard and derive safety goal, safe state, FTTI, ASIL, and build safety mechanism to achieve the safety goal and in the event of a failure, and transfer to system to the safe state. Device solution. So MCU and PMIC use RH850, CYMA2, and RA270,000. System designer can take advantage of SEOC's work products. This MCU has two channels of RDC that resolve a digital converter and can control dual E motors. In addition, boost back control can be realized on a single chip. Safety functions suitable for motor control, such as PWM loopback monitor and emergency shutoff, are also included. This PMIC includes safety functions such as supply voltage monitoring, Q&A watchdog timer, and error monitor in conjunction with the MCU. Please click on the link for more information on each product. This inverter system targets SLC. Reference work products created by Renesas were reviewed by SGS Japan, a third-party organization. And Renesas obtained a technical report for the ISO 26662 functional safety concept phase. You can refer to a concept level safety analysis based on a widely accepted and typical assumption item definition. Finally, in summary, the above. The functional safety concept for the xEV inverter system will shorten your development time. Easy to start system development, targeting SLC, reviewed by SGS Japan, utilize develop device MCU PMIC SEOC work products, and enable development based on Renesas xEV inverter reference solution, flexible configuration for various inverter systems. If you are interested or have any other inquiries, please click on the link for your request information to our site. Thank you very much for your attention to my explain so far. I will switch to Okuda-san again.
So thank you very much for explaining xEV inverter, Tsubota-san. So I'd like to leave our session today. So by highlighting where to go for more information. So the first of all, so Renesas is contributing to the acceleration of customer development through our winning combination system solutions. On the BMS, so our BMS application model and the software solution so reduces R&D effort by providing sample application models that estimate state of charge and the state of health. On the inverter, so optimization of these safety functions requires time-consuming for the system-dependent safety analysis and evaluation. So Renesas can help customers shorten development time by supporting functional safety at the system level. Okay, so and as a conclusion, so you can find much more information from our website. So from there, so you can discover more about our winning combinations also. So please invite our public website. So this is the end of today's session. So thank you very much.